Hello and welcome to a new episode about using FreeCAD to generate toolpath on the CNC. In this episode I'm going to show you how I made this very nice button to celebrate 1000 subscribers. First of all, let me thank you all for hitting that subscribe button and following, appreciating, sharing, liking my content. I know I haven't been the best in all of my videos, but I'm trying to improve every time, so thank you a lot for supporting me, and I promise I will get better with each video. In this episode I'm going to show you how I made this sign. It seems pretty easy, but it was very complicated because the 3D capabilities of FreeCAD are yet pretty limited. There are some functions for 3D such as 3D pocket or 3D surface, but they are pretty buggy for now, and I had to improvise a lot along this project. So let's get started, but not before telling you about my Patreon account, about the possibility to support me, to help me improve what I do, to help me keep on doing it by subscribing to my Patreon or by purchasing just a one-time thank you of a $3 thank you or a $10 big thank you. Let's get started and let's model this sign, and then let's go to the CAM workbench and prepare the G-code to mill it on the CNC. I'm in the part design workbench. I will start by creating a new body and then a new sketch. I'm going to use this sketch to create a simple sphere which I'll be using to make an intersection later in the part workbench in order to create the nice top section of my button. And I will use a few tricks to get the shape correctly positioned each time, even when I change the dimensions of the rectangle or the radius of the corners or even the radius of this sphere, which will ultimately change the top surface of my button. So I will select the XZ plane this time. Just as for any revolution, I'm going to create half of the profile. I will create an arc with the center in the origin. It will start from the y-axis and end also on the y-axis, a 180 degrees circle. And in order to be able to make a revolution using this sketch, I will have to close it by creating a line from these 2 points. So I'll select the line tool, close the sketch, select it, click on the revolution button, and I will leave the default angle of 360 degrees, and now I have a sphere here. I'm going to use this sphere to intersect it with a square, padded rectangle actually. I'm going to intersect them and get the base of the surface that I'm going to use to create the button. So create a new body, and I will name them now so it's easier to understand each object. So this one will be sphere and this one rectangle. I will create a new body in the rectangle on the XY plane this time. Click on the OK button, click on the show section to view everything, and I will use a centered rectangle. I usually place my designs in the positive X and the positive Y, but this time, because I'm using a sphere, I'll be centering everything in the origin. So I will create a rectangle. Let's give it some dimensions. For my sign I have been using 250 millimeters length and 130 width. You can see it's pretty huge compared to the sphere, so let's close this, pad the rectangle for 35 millimeters, and now we have to make the sphere so large that on the top surface of this rectangle I will only have a slight roundover from the top of the sphere. I could have used the surfaces workbench, but I don't like to use that way because I cannot modify anything. Getting the correct design and maybe adjusting some dimensions and being able to do it along the way without a lot of operations is pretty important to me. That is why I prefer to take the part design and part workbench route all the time if possible. Of course, sometimes it is not possible and I have to resort to other alternatives, but now I can do this. So let me show how to get that very nice smooth round surface without using a mesh or a surface, because the surface is pretty difficult to modify after creating. I want the top of the sphere to start from this line to this line. This distance is set in the sketch that defines the path. So double click on the sketch, select this constraint, and I can see it here in the list. Also, if I double click on it, this little window pops up and I can write a name, rectangle length. And now if I go to the sphere sketch, the sketch that defines the revolution, let me hide everything up to the face of the sketch. I want a line here to be equal to the length of the rectangle and properly fit inside the top of the sphere. So how do I do that? First, let's draw the line. Of course, I will randomly draw it, and I select both ends, and after selecting both ends, select the y-axis and give a symmetrical constraint. And I want the length of this line, so press L, to be equal to the length of the rectangle that I have drawn before. Of course, I can use an external geometry, a shape binder, but I don't like that approach because sometimes it throws some errors. So I will go to the length, click on the formula, start writing sketch, and after that I will write constraints, and then followed by a dot, rectangle length. And I have my dimension that I've set there. Whenever I change it from that sketch, it will automatically update in this sketch too. And now I have to solve two more problems. I want this arc to pass through this point, so select them both and use the point on object constraint. One more thing, I want to have a certain distance between this line and the top of the sphere. I want a certain curvature on my surface, so select this point, select this line and set a distance constraint. I will give it a value of 10 for now and also give it a name, curvature height, and I will be able to reference it from outside this sketch. You can see that it popped up very high because it is a huge diameter sphere. Now that's not a problem for me. I have to select this line and change it to a construction geometry, otherwise the sketch will fail. The next thing to do is to move the sphere, to lower it up to the face of the rectangle. So let's go back to the sketch of the revolution. I want this point from the arc to be exactly on the top of my rectangle. So I will go to this button to change it to reference constraint and set a vertical distance constraint. Double click on it and also give it a name, height offset. This is the offset that I need to change for the sphere, to move it downwards in order to touch the top face. Well, not this distance actually, because I will also have to take into account the height of the rectangle, but it's easy to enter a formula. So after setting this constraint, after setting its name, height offset, close the sketch, go to the sphere, and here I have placement position and I will change the Z, press equal to enter a formula, and let's start writing sketch dot constraints dot height offset, and I have to multiply this by -1, and now you can see it barely touches the bottom of the rectangle, but I want it to barely touch the top of the rectangle so I can make an intersection. For that I will have to modify this dimension. I will have to add the pad dot length. So let me press enter, close the formula, and you can see here the pad and its height, it's set by this variable, the length. So moving the sphere back upwards a little with this value will result in a perfect intersection here. And now with these two bodies ready, I can select them both, go to the part workbench and make an intersection. But there's something that I don't like, that when first creating the model didn't appear, and now I have to understand why. It's this line. So if I turn on the sphere, you can see that it is defined by this arc and this line intersects the model. How can I solve this? Well, since it's just a sphere, I can go to the sketch and modify its attachment support from the XZ plane to the XY plane. Make sure to unselect the XZ plane, and now after recomputing, you can see the line that defines the sphere is here, and here for my intersection there's absolutely no line on this face. So I can turn off the visibility of the sphere now, and I have the shape that I want. And theoretically this surface should be just a single surface, but I can see here a little dot. This little dot, which might seem harmless, will most probably generate a lot of issues when moving onto the CAM workbench, so I'd rather get rid of it. How do I get rid of it? Go to the sphere, go to the Z position of the sphere, and simply move it just a little bit higher, which is by subtracting a 0.01 millimeters. Click OK, and after the refresh you can see the little dot disappearing, and this will make things much easier. Now I have a very nice, a very smooth surface, curved in both directions. It might seem a little bit complicated what I did here, but let me show you why it is a good thing to do, because it will be very easy to modify a lot of things. So if I go to the rectangle, double click on the sketch, I want to change its length, I will change it to 350 millimeters. Click on close, you can see that everything automatically updated. I still have the same curvature, I still have a single surface. Let me also write a different width for the rectangle, let's say 300 millimeters. Click on the close button. Of course it does have some limitations. If I set a height higher than the length, some weird things will appear. Let me write here on 800 millimeters. Click on the close button and you can see a pretty weird surface. As everything, there are some limits, after which you have to understand that you have exceeded some limitations, so just set a width lower than the length. It's a normal thing, so let's set 200 millimeters. Now you can see that everything looks okay. Let's check the limits also to the roundness of my button. Let's go here and modify this value. First I have 10 millimeters, I will give it a value of 2 millimeters, which will result in an absolutely huge sphere, but the surface is looking good. It's the same as it should, and you can barely see it is curved, but it is curved. If I take a look with a sphere visible. You can see the rectangle is just a tiny piece in this huge sphere. Everything updated automatically. You can see the Z position of the sphere changed. And now let's check the other limit. So basically in the lower limit, probably writing 0 here will result in a very bad thing because it will be an infinite sphere. Let's test the other end. Let's write a length of 25 millimeters. Everything went much smaller this time. Click on the close. You can see that I already have some problems. The curvature goes almost all the way down, and that is a normal thing because if I have a rectangle with a 35 millimeters total height and I'm going to cut this curvature from its top, even though first I expected to have 10 millimeters here in the corner, then I realized that the 10 millimeters are in the center of this side. So since this is curved too, it will result in a much lower distance here. So let's get back to the 10 millimeters that we initially set here. Click on the close, and now we have a pretty decent looking rectangle. As you can see in the images, my design was not an actual rectangle. It has very nice fluid rounded corners and rounded edges. So let's get back to the sketch of the rectangle and modify this simple rectangle to turn it into a very nice looking shape, similar to a button that you might see on a computer. First, let's go and take the Create Fillet tool and click the edges one after the other. And now we have 4 rounded corners. And now let's make all these corners equal. Select them by holding Ctrl and press the E key for an equal constraint. And the next step is to turn these lines, the 4 edges, turn them into construction geometry. Because I don't want those to be visible, I will replace them with some very nice arcs. So go to the Create Arc tool, click on the little arrow and select the Create Arc by 3 points. It will be easier in this situation. Select the first end, the second end, and then by moving the mouse up and down, click somewhere and you have the correct arc. I will do the same for the bottom. And you probably have noticed that there are no constraints in the corners. The points are white in the ends of the arcs. That's because I have turned off auto constraints and auto remove redundants for this sketch, because it is quite complicated to do what I'm doing here without those turned off. And I will continue with the arc for the 2 vertical edges. Now let's take a closer look. You can see here the edges are very sharp. We need to make them tangent to make them continuous, and for that I will first remove this tangent constraint which is between the rounded corner and the horizontal of the initial rectangle. I don't need that anymore. After deleting it, I will select all the points here and press C for a coincident constraint, then select the first segment, select the second one and press T for a tangent constraint. And I will repeat the same process for all the corners and for all the intersections between the rounded corner and the slightly rounded edge. So first delete the tangent constraint, select the points, press C for a coincident constraint, and then select the 2 lines and create a new tangent constraint. If I select from left to right, you can see that only the points are selected. If I select from right to left, everything that the selection is touching gets selected. And this might be useful in certain situations, so you have to remember that dragging from left to right will only select the elements that are fully inside the selection, not only points, because if I drag from left to right, including this whole line in the selection, it also gets selected. So from left to right, anything that is fully in the selection, from right to left, anything that touches the selection. And after doing this for all the corners, I can move on and set a radius for these 2 and for these 2, but first I will select the opposite ones and make them equal. Do the same for the opposite vertical ones, press E to set them equal. And now you can see here I have 3 degrees of freedom. One is the radius of the corners. Select any of the corners, press K then R to set a radius. I will give them a radius of 50 millimeters. I still have 2 degrees of freedom, which is the radius of this curve. So to set the radius, you can see here is the center point for this arc and here is the center point for this arc. Let me just give a name to this constraint too. I will name it rectangle width. Now I can reference it because the radius of this segment will be dependent on the total width of the rectangle. So press L to set a distance constraint. Ignore for the moment that it shows some redundant constraints. Press equal and I will write constraints dot rectangle width and I will divide it by 2. And sometimes have to delete a constraint, drag the point a little bit and then put the constraint in its place again. Everything works. So constraints rectangle width divided by 2, and now you can see everything works. I have only 1 degree of freedom remaining, which is the radius of this and this arc. I will set it for the bottom one, the center point is here. Since they are equal, it will also be constrained for the top arc, so press I for a vertical distance constraint, and I will use here also a formula, which is constraints rectangle length multiplied by 2. This time I will multiply it. I don't really need to set this exactly as a formula, but since it looks proportional, I think it's okay like this. And when I close the sketch, you can see the shape of the button updated, but I still have something that is not right in the sketch. If you take a look, I have a total distance of 350 millimeters, but that's between this line and this line. The same applies for the vertical, so my button will actually be a little bit larger than the rectangle. I don't have the auto constraints turned on, and I want them. For now I will also turn on auto remove redundants. Now let's place the points. You can see here I have an automatical point on line constraint, the same here, and I will do the same for the vertical. So place 2 points somewhere outside of the rectangle, of the shape actually, not of the rectangle. Right click, select the point, select this line and press O for a point on object constraint, and I will do the same for all the 4 points. And now instead of distance between these vertical lines of the former rectangle, I will change them to be the distance between these points, which are the very tip of the shape that I'm creating. So delete this, select this point, select this other point, press L again, and I will write a value of 350, and remember to give it the name back, because otherwise everything will break. So the name was rectangle length. You can see everything shrinked a little bit. Let's do the same for the rectangle width. Delete the constraint, select the point, select the bottom point, press I for a vertical distance constraint, write the length of 200 millimeters and give it a name, rectangle width. Now everything is constrained correctly, but I will use a 130 millimeters, a length of 250 millimeters. That's the dimensions of the stock that I have. I will also change the radius to 25 millimeters. And now let's create the pocket for the intarsia. This will be pretty easy. I will go back to the part design workbench, create a new body. Inside this body I will create a new sketch in the XY plane, and then I will click on the view section button. Let's create another centered rectangle, and I will give it a length of 120 millimeters and a width of 40. Now let's make it a little bit nicer. Select the fillet tool again and click the edges one by one to make rounded corners. After that, right click, select all the 4 corners and press E to make them equal. I can finally select any of the corners, press K then R to set a radius. I will give a radius of 5 millimeters, and now I have the shape of the cutout for the intarsia. So I will close the sketch, and now select the shape of the button, press space to hide it so we can easier work on this body that is going to be the intarsia. I will make a pad of 6 millimeters. I will turn back the view for the common and modify the height of this body, change its Z to the pad length, and if I press enter, press tab, you can see that it is aligned with the button, but it is aligned at the bottom face. I want it to be aligned at the top face, so I will have to subtract from this formula its own height. I will subtract the pad 001 dot length, which is its own length. Now you can see it barely touching at the center of the top of the button, but I want it to have the same shape. So for that I will open the common, select this body, hold Ctrl and select the sphere, then move to the part workbench and create a new common. If I turn off the other common, you can see now I have the correct shape with the correct curvature matching the other object. Of course the other object doesn't have a cutout yet, so to make that I will select the large common, then hold Ctrl and select the other common and create a cut. The second common disappeared, but I can anytime open the tree, press space, and I can see it here. Now I have the 2 main parts of my project. I still need to make a cutout in this part with the shape of the bell and the 1000 text. As you can see here in the tree I have 3 objects. I will rename this intarsia, and the other cut I will rename it button body. Also rename this one to be easier to find, button without cutout. Now let's make some tests. Let's open this and double check that everything, all the relations are correct. Let's change the height of the pad. Let's make it 40 and make sure the intarsia is moving accordingly. You can see it's still flat, so everything is okay. Let's also change the dimensions of the rectangle. Let's make it 300 millimeters long and 180 millimeters wide. Everything is still okay. Because I have placed everything with the center in the origin, I don't need to move anything around. With the other approach, which is better for other things, I would have had to modify also the X and the Y using some formulas. It's a little bit more complicated, but it helps with other things, and we'll talk about that in another episode. One more value that we still have to modify and make sure everything is okay: the curvature height. Let's make it 15 millimeters, close, and everything is still looking great. So we basically have created a fully parametric model with just a couple of relations between some values. Anything that I change updates accordingly, and everything stays in place. That's the beauty of FreeCAD. When modeling, you can do this, and even though you might only make a thing once, making it parametric makes it much easier to modify the dimensions, to adapt the radiuses until you get something that you are very satisfied with the way it looks. So let's change everything back to the initial values, and let's move on to create the cutout for the text. I will first open Inkscape. I have downloaded the subscribe button on the internet. So in Inkscape, go to File, Import, change it to all images, and select the image that you have downloaded. And I want this little bell, the sound symbols next to it, I want them to be placed on my button. With the image selected, go to Path, Trace Bitmap. Since this image is pretty clear, the lines are very clear, the default values will work okay, so click on apply. And now I have two objects, one on top of the other. Let's move the traced bitmap away, select the initial image and simply press delete. We don't need it anymore. Now double click on this, you will enter the path tool, make a selection, press Ctrl C, move out and press Ctrl V. Now I can also remove the rest of the traced image, I don't need it. Now I want to remove the black outline. How do I do that? Double click to enter the path editing tools, press Ctrl, scroll your wheel mouse up, and it will automatically select all the control points on the connected edge. Press on delete, and now I have a simple path with a shape that I want, with a bell and the sound symbols. Now select it, go to File. I will check export selected only because I want the image to be just this size. I will export it as plain SVG. Also select the path because the default is somewhere in your user folder, so give it a name. It's pretty difficult to select something with this huge mouse pointer, so let's call it YouTube bell.svg. Press enter and the job in Inkscape is done. Close Inkscape. The first thing that we need to do in FreeCAD is go to File, Import, and I have the YouTube bell file here. Click on Open. I have several paths. I don't want this, I want to have a sketch. For that I'm moving to the draft workbench and I will click this button, draft to sketch. It will automatically convert all the lines to a single sketch, so I can now delete the imported lines. Press GR to hide this annoying grid that is shown up, and I think it's useless. Now I still have to do something. In the draft workbench I will use the shape from text tool, change the string to 1000. This is the text that I want to appear. I will give a height of 17 millimeters. It has nothing to do with the size. Select a font file. You will have to download different fonts. I have my fonts folder here. You have to download the TrueType in order to be able to use this ShapeString. It simply doesn't work with the system fonts as in any other program. And as you can see, I've selected the wrong font file. Another downside of selecting a font file is not knowing the preview. So I finally managed to find the correct font, and the ShapeString is placed somewhere, rotated by 2 axes, moved. That's the downside of the draft workbench. Places objects based on the rotation of the view, so it's pretty annoying, but it's easily solvable. Just go to placement, change the angle to 0, also the axis to 0, and the position back to 0, and we can start from there and change the position. Now let's place these two shapes on top of this body in order to make a cutout and move on to create the real object. So first I will set a top view, and since one is a sketch, one is a shape string, I want them to be just one single object, so I will select the shape string, use the same draft to sketch, and now I can delete the shape string. I have a sketch defining the text. Double click on it, select everything, press Ctrl C, close the sketch, open the sketch with a bell, and now press Ctrl V. I still have to move them around, so select the 1000, select the move tool, which has a pretty weird symbol, but it works much better than in the previous versions. So move it to make room for the bell. Now select the bell, move it also. Make sure when moving objects do not overlap them, because it will be very difficult to later center them. I need to make a little rectangle, so I will turn on construction geometry. But before creating the rectangle that will define the place that I have in order to be able to scale everything correctly, I will move them away. As I've told you, selecting them after placing them over other objects is pretty difficult, so move the bell away. I will use the same technique. I will also create a centered rectangle. I will give it dimensions a little bit later, because I also have to move the 1000 from here. And now let's give some dimensions to this rectangle, because it doesn't have any dimensions. So select the bottom, press L, let's give it a length of 120 and a height of 40, just as the piece of wood that we want this to be placed on. Now I can select the 1000, select any point, move it inside this rectangle, and do the same with the bell. And I think we are going to need to scale it a little bit, so select the scale tool, select the point, select the direction, and then just scale it. You of course can do it using numbers, it's much easier, but for this project I simply don't need to be that precise, and I think I still need to scale it a little bit, otherwise it will be just to the edge of the piece of wood, and this might result in some broken pieces. I modified the dimensions because I remembered that this piece should be 150, not 120. So go back here, go back to the body, to the pad, to the sketch that defines it, and modify this dimension to 150 millimeters. It is that easy, everything updated, and I can now place this sketch on the top face of this body. Well, I won't be able to place it on the top face of this body because it is rounded, as you can see. I could go to another workbench and do that, but since my CNC is only 3 axis, it won't be able to respect the perpendicular for each part of this segment. So I will just use a simple perpendicular cutout. Let me just delete this sketch with a 1000. I have already copied the shape, so now I will take this sketch, and as you can see, this is not a part design body. In order to turn this into a part design body and be able to make a pocket, I will select it and use the clone tool, then move the sketch into this body, and I can now correctly place it above this and make a cutout using the shape in the sketch. But as you can see, there is a little problem with this type of approach with a pocket. No matter where I place the sketch, it will result in some weird behavior, probably because of the curvature of this face. I will delete the pocket. I can now delete this body, I don't need it anymore. I will select the sketch, go to the part workbench and create an extrusion, and here I have by default a length along 10 millimeters. I also have an option against. Along means from the plane of the sketch upwards, so I will set it to 0 and set the against to 4 millimeters because I want it to go downwards. So I will click OK, and I have this shape extruded. And now with the intarsia selected, hold Ctrl down, select the extrude and press the cut button. I now have the correct shape for the intarsia with a cutout. This will be made out of a darker wood, and if I turn on the button body, you can see that it already looks similar to what I've shown you that I have achieved in the start of the video. Let's rename this cut also intarsia with inlay pocket. And now we can move to the final step. Go back to the part design workbench, create a new body, create a new sketch again in the XY plane, click on OK, hide everything up to the sketch, and make the same type of centered rectangle with a length of 150 and the width of 40. I will hide the button body, and with this sketch I will only create a support for the cutouts for the bell and the letters. So I will pad it for just 2 millimeters and then move it on top of the bottom body. Body placement position, go to the Z value, press equal, and right here pad length. This was the length of the initial rectangle height. It is correctly placed. Hide the button body. I will also hide the intarsia with inlay. I just want the letters to be raised here. So the letters are the extrude. I will select this body, select, hold Ctrl and select the extrude, go to the part workbench and use this button to make a union. And now I have this fusion, which is the correct shape that will match the intarsia with inlay pocket. So these are all the pieces that I need. I still have to make some roundovers along these edges and along the intarsia. I won't be creating fillets on this shape because when moving onto the CAM workbench it will create a lot of problems, which I don't want. So let's leave it like this, and then we will be able to mill everything a lot easier. And now that I have created all the 3 bodies that I have to mill, let's hide the second ones and we will start with the main button body. In order to get its final shape, I'm going to use 4 operations: 1 pocket for the center recession for the intarsia, 1 3D surface for this face. Well, it's not going to be a 3D surface because it doesn't do what I want to do, so I will show you an alternative way. A profiling operation to cut the outline of the body, which we will modify using a tag dress up in order to be able to keep the button on the CNC table. And we will also add some roundover for the external and the internal top edges. For that we will emulate a 3D engrave operation. I will show you how to do that too. So let's get started. Let's first create a new job. I will make sure the button body is selected. Click on the new job button. You can see that I'm in the CAM workbench. Also check in the list with the solids that you have the correct element selected. Click on OK. The origin is in the center of my button because I have created, as you have seen in the first part of the video, I have created everything by centering every shape in the origin. This is something that I don't usually do, especially because I want to have the origin in the corner, but I can anytime change it. So I select the corner, make sure the extension, the start extension on the X and on the Y are 0, and then click the set origin button. Now go to the tools tab, click on the add button, and we will add 2 tools, one 5mm end mill. I will use this end mill to make the central pocket, to mill the outside. For the roundover I will emulate the movement using this bit. It doesn't really matter what bit you have selected, so I will use it for 3 operations. I will also use it to make the rough cutting for the facing operation, and then for the finish pass for the facing I will use a 1mm ball end tool bit. After adding all the tool bits that I need, I can remove the default tool, which is pretty useless, and I will make sure I have vertical and horizontal feed speeds and of course a spindle speed, otherwise the cheat code will simply be unusable. I will give to the ball end higher speeds because most of the material will be removed and I just want a finishing pass and I want it to happen very fast. For the 5mm end mill I will give lower values because I want it to cut very smooth and to avoid any splintering or whatever damage might happen. I can now click OK to close the job, and let's do the first simple operation. Select the bottom face of this pocket, click on the pocket shape button, select the appropriate tool controller. I will use the 5mm end mill as I've told you. Click on the OK button, and now let's set up things for the pocket operation. I will set a pattern of zigzag offset. I will also set an angle of 0 degrees because I want it to move along the x-axis. I will change the step over to 80%, and I can now click apply to see the generated G-code. Everything seems okay except the step down. So go to the depth tab. Here I have a step down of 5mm, which is too much for my CNC, so I will change it, but as you can see I cannot click here and modify it because it is written as an expression. So I have to press this button to edit the expression. I will simply click on clear, and now I can write a value here. I will use a 2mm step down. Click on apply again to make sure everything changes accordingly. The pocket seems okay, so this is the simplest operation out of the ones that we are going to make. Click on OK and we are done with this operation. The next operation that I want to make is to make a rough cut with a 5mm end mill on this face, to make a facing operation with very far away passes, just to remove most of the material, to make room for the 1mm ball end to leave a very nice finished surface. And even though it should be easy, here start the problems and I need to improvise to hack the CAM workbench in order to get what I want. Let me first hide the pocket shape so you can clearly see. The normal workflow would be to select this face, go here and create a new 3D surface operation. Make sure the base geometry is correctly selected, so it should only make a 3D surface operation for this face. But if I click apply, you will see that it also goes through the pocket, which shouldn't be a problem because I have already milled it using the pocket operation. But here there will be some issues. At the corners it calculates a little bit wrong and it will mill a little bit too much material, which I don't want. And no matter what settings since I try to use it, simply won't avoid this portion of the MillFace. I have checked the bug reporting system and this bug is there reported for more than 2 years. It hasn't been solved yet. It's probably much more difficult to solve it than it appears when simply looking at the interface. So let's find a solution to only mill this face, because there will be situations when you will need to make a 3D surface excluding other surfaces and you simply cannot do it using the 3D surface operation. So I will click on cancel. To be able to make a 3D surface operation for this face using the 5mm end mill, I will have to use a hack. So I will go to the draft workbench, select the body, set a top view. It's essential to set a top view, otherwise the projection will be the one that you see in the viewport and the shape will be skewed. After selecting the top face, click on this button, which is Shape 2D View. And now if I rotate the view again, you will see that I have the outline of this face here at the bottom of the 0. Press GR to hide the annoying grid, and with this Shape 2D View I should be able to go to the part workbench and create a face, but it will throw an error, wire is not closed. Not sure why it does it, because obviously the wire is closed. But let me show you how to solve this. Go back to the draft workbench, select the Shape 2D View and click on this button, draft to sketch. Now I can delete the shape and I have a sketch which is exactly the same lines that were in the previous object. But now if I go to the part workbench and select the sketch, click on the make face from wires, and now I have a very nice face here which doesn't have any unclosed wires, even though it's the same shape. So now I will double click on the job, go to the general tab, click on the edit button next to the model, and here at the 2D I have the face that I have just created. I can click on OK and now it is part of the job. So now that we have created the additional geometry, let's go back to the CAM workbench, rotate the view and select the bottom face that we have just created. You can see here it automatically selected it in the tree. If it doesn't, maybe you can try to hide different objects until you can select it easily. And for this I will use a MillFace operation, a standard MillFace, not a 3D surface operation. I will first click on apply to see what happens. Everything is a mess, so let's adjust some settings here in order to get the correct shape. First of all, for the boundary shape I will change it to face region, and I can see the exact same problem as with the 3D surface operation, but this time it is a reason for that. It's because it has to mill also the entire body to get to the 0 position. So this time it's not a bug, it's just a consequence of the fact that I have two different objects in a single job. But I will ignore the fact that it passes over the central area. I don't really care about that. I just don't want the cutter to drop into this area and damage the edges. I will change the pattern from zigzag to zigzag offset, setting an angle of 0 degrees in order to have cut lines parallel to the x-axis. And now I can click on the apply button again and I can see I have exactly what I want, parallel lines on the x-axis and a final outline of the entire shape. But I have a lot of layers and I don't need those layers. I just want to mill this curvature, which is about 7mm, so 2 layers should be enough. For that I will go to the depth tab, and instead of 34.78mm start depth I will edit the formula and enter a start depth of 7mm. Click on apply again and now I only have 2 layers at the bottom. You might ask, why do I need these layers at the bottom? I will show you in just a couple of seconds a trick that I'm using in order to mill this face using a simple MillFace operation. Click on the OK button to close the MillFace. Now select it and go to the CAM menu, go to Path Dress Up and select Z Depth Correction. Click on OK. Here don't modify anything, and now let's make the magic happen. First of all, go to my Patreon page. You can find the link in the description of this video. Go to collections and here you have a collection called FreeCAD Macros. Make sure you search all the list because the order of the macros might change. I might add more things. Here you will find the FreeCAD Add Faces Guide to Z-Depth Correction macro. The file name is a little bit different, but it doesn't really matter. Just click on it and save it somewhere where your macros are saved. You don't need to log in, you don't need to subscribe. You can simply download it for free from that page. Of course, if you want to support me, you can subscribe to any of the the tires, or simply go to the shop and buy one of the two products, the one-time thanks and the one-time big thanks. But any type of support, no matter if it is a one-time thank you, if it's a subscription, or even if it doesn't involve making a payment, simply sharing, commenting, liking my videos is a lot of help. So now let's go back to FreeCAD and use the macro that we have just downloaded. In order for the macro to work, I have to first select the Z-correct dress up, then hold Ctrl down, select the face that I want to be used as a guide, then go to macros. Here you should find the macro that you have just downloaded if you place it in the correct folder. If you don't know where to place it after downloading it, just open the execute macro menu, and here you will find the use macro location where you need to place the file that you have downloaded. After that you will find it in this list, select it and click on the execute button, and now it will take some time to recompute. You will see the magic happening, getting a 3D surface operation. Depending on the operation that you are using and correcting using the Z-correct dress up, set at front view, double check that there are no toolpath going down, because for the pocket operation sometimes if you don't set the correct clearance and safe height for the operation, you might end up with some cutter movements below the surface, which is something that you don't want to happen. Another thing that I want to correct, you can see here the final pass is exactly on the face, which I don't want for two reasons. First of all, imagine the cutter being a round cutter and being flat on the XY plane. It will mill a little bit more material. So depending on the slope of the face, I will need to set an offset to raise a little bit the toolpath. So let's lift the 5mm and mill 1mm. Let me show you how to set that offset. Double click on the initial operation, go to the depth tab and change the final depth. Instead of 0, I will set a final depth of 1mm. It will take some time because it will also recompute the Z depth correction. And now if I take a closer look, I can see that the final pass is slightly higher on the face. As I've told you, I will solve that using the 1mm ball end, which will also leave a very smooth surface. So since we already have this operation, let's duplicate it using the copy the operation in the jump command. I now have a second MillFace. I will rename it. If I take a look, it sits on the bottom because I don't have a Z-correct dress up anymore. Let's modify the parameters first. Double click on it, change the tool controller from a 5mm end mill to the 1mm ball end, and I will also change the pattern from zigzag offset to zigzag. I don't need the outline because the parallel lines are so close to each other that I simply don't need an outline cut at the end. I will also change the step over percent 30%, which will lead to a 0.3mm offset for each pass. Is enough to get a pretty smooth surface. So these are the settings that I'm going to use. I will click on apply, go to the depth tab and change the start depth, because I don't need a start depth of 7mm. It has already been milled using the 5mm Toolbit, so I will have a start depth of 1mm. Also modify the final depth to 0 in order to mill everything correctly this time, and leave the step down to 1mm, so I will only have one pass. We need to repeat the same trick with the Z depth correction, so select the face, go to CAM, path dress up, Z depth correction, click on OK, select the operation, zoom in to select the face holding Ctrl down, go to macros, recent macros this time because I have just used it, and add surface to Z depth correction. Now the operation using the 1mm ball end is also correctly placed on the face. It will also pass over the pocket in the middle, but it will pass over, so that's not a problem. If I want to make things faster, I could use a pocket surface which will take into account the actual shape. The MillFace doesn't do that, just like the 3D surface. I'm not sure why they don't take into consideration the inside. If they are enclosed in the surface, they will be milled, they won't be avoided, and I think this is a big problem. I still need to do two more things, so click on the job, don't select anything, and click on the profile tool. Here in the settings I have to take care to select the proper tool controller, because as usual when creating an operation it will by default use the tool that has been used for the previous operation. So change the tool controller to the 5mm and mill, click on apply to make sure everything is okay. It is almost okay because I want to modify the step down. Again, it is 5mm, it's too deep, so I will manually write a value of 2mm, and now I have a lot of layers. the next step is pretty complicated. It does a simple thing, but it does it pretty weird, because there's no such function as deburr, a 3D deburr or a 3D engrave or anything similar. So I'm going to use again a little trick. You will see along setting it up that I need to make some additional geometry also this time, because I will run into a problem. If I select the bottom face and click on the profile operation, let me just make some modifications. I will uncheck use compensation. This means that it won't take into account the diameter of the toolbit, and it will only move along the exact edge that is selected. If I set a top view, you will see that the toolpath is exactly where the line is. So basically this is an engrave operation. I don't like the fact that it has a lot of layers, so I will set a start depth of 1 mm and the final depth of 0, leaving the step down as it is. Now I have only one pass here, but I have a roundover bit which needs to be set to the outside 2 mm and lowered 2 mm. The tip of the toolbit needs to have these values. It depends on the shape of the toolbit, so you will have to measure and calculate these values, but once you know them, write them down somewhere, so you know when using a certain toolbit you will have to move the toolpath a little bit to the left, the right, or up or down. It doesn't matter, you can do any of those things. So if I want to move it towards the outside 2 mm, I will go to the extra offset field, set an extra offset of 2 mm, and here you can see the toolpath has moved outside of the body 2 mm. I also know that for my toolbit, in order to get a correct roundover, the tip needs to be 2 mm lower than the surface that I'm cutting. For that I go to the depth tab and set a final depth of -2 mm. Click on OK, click on apply, and make sure the toolpath now is lower than the object and to the outside. And now I should be able to do the same thing as I did with the MillFace. Go to the CAM menu, go to Path Dress Up, Z Depth Correction, close this menu, and now select the Z Depth Correction and the face. But when running the macro, you will see an error. List index out of range. And to explain it very shortly what is going on, let's set a top view, and you can see the line is outside of this 3D face, so FreeCAD doesn't know how to place that line on this face, so let's fix that. Let's go to the surface workbench, select the top face, click on expand button, and now I have a surface larger than the face that I have selected. I can even hide the body, and you can see the surface, which should be exactly what I need in order to correctly place the profile, to lift it and to make a 3D engrave operation out of it. But selecting it and this face and then running the macro will also issue another error, undefined surface type. I believe this is a 0.22 bug, not sure if this is the case, but I believe so, because in order to make this work I had to go to 0.21, open the file, apply the correction to this surface, and then everything went okay, moved back to 0.22 and continued to do what I had to do. So let's go to 0.21 quickly and make the modification. Close the file here, you will find it under Open Recent, select the Z Correct Dress Up, hold Ctrl and select this face, go to Macro, Recent Macros, add surface to Z Depth Correction. The debar operation, let's call it this way, is now at the correct height and everything should be okay. I can now save the file, close FreeCAD 0.21 and reopen it in 0.22, where everything seems okay. Of course, there's no problem, doesn't matter even if I hit the recompute button, as long as I don't change the actual surface, there won't be an error. I can also edit the profile operation, there won't be errors other than when applying the surface to the Z depth correction dress up. I will repeat the same thing with the Z depth correction, moving to 0.21 to apply to the surface, because this one will be to the inside and I will also get the same error after creating a profile operation with these lines selected. Let's do this quickly, hold Ctrl down to select all these lines, create a new profile operation, use compensation unchecked, go to the depth tab, change the start depth, also change the final depth because I know it's going to be -2 mm, and change the extra offset to 2 mm. So once this is done, I will go back to 0.21, apply the Z Correct Dress Up, we have everything ready for this part of the button. We will still have to do the intarsia and the mirrored inlay in order to fit them together. But after milling, when having to change the cutter to the roundover toolbit, I have to make some room around the piece, so I will repeat the profile operation, the operation that cuts the outline, and I will repeat it by pressing this button, double clicking on it, setting an extra offset of 5 mm because I have been using a 5 mm, and mill set a final depth of 15 mm, and this should clear enough space in order to fit the roundover toolbit. Click on OK, and just to make sure, I will repeat the process, duplicate the profile operation again, set an extra offset of 10 mm. This way I will make sure that the roundover cutter toolbit will fit between the stock that I want to mill and the remaining parts of the stock. And now let's hide everything, hide the operations, hide the model, hide the stock, close the job in the tree. Let's turn on the visibility for this piece, create a new job. You can see the origin is not correctly placed, so select the corner, click on the set origin after making sure the extensions on the X and on the Y are 0. Go to the tools tab, add a new tool, the 1 mm end mill, add another one, the 1 mm ball end, remove the default tool, set some speeds. For the end mill I will set very low speed, 700, both on vertical and horizontal. For the ball end I can use the same 3500. I'm setting such a small speed for the end because it is going to mill all these pockets which are very small. The remaining walls are very small and I don't want them to break. Let's do the facing operation and the same hack using the Z depth correction. Now after milling the top surface, I can go on and mill the pockets. For that I will select all these faces and hold Ctrl down, create a new pocket operation, change the tool controller to the 1 mm end mill, change the pattern to zigzag offset, change the step over percent to 80, and then clicking on apply I should see the correct toolpath for the pocket operation. Even though the toolpath is with a square corner, of course using an end mill will result in a roundover. This wouldn't be a problem if I didn't have to fit another piece inside of this one. To solve this problem I am going to have to edit the sketch and add some fillet for these corners, for the sharp corners, in order to avoid any problems when fitting the two pieces together. And now everything should fit. I still need to mill the outline with some holding tags and of course mill the roundover. So I will do the same just as I did with the main body of the button, make a profile. And even though I've told you that I was going to use the same technique to round over this edge, I've decided along the way that it's much easier to slightly sand it by hand. I've shown you how to use it because sometimes it might be very useful. One thing that I forgot to mention about using roundover bits or V-bits for chamfering or beveling the edges is that depending on the slope there will be some differences. Since the Z-correct dress up is just a projection, here it will mill a little bit more than at the top, so you have to take that into account. If the slopes are very light you don't have a problem with that, but if you have very sharp slopes you should really take that into account and maybe find another way. And now let's hide everything and move to the final operation, the one for the fusion, which is the negative, which will fit in the intarsia. So select it, create a new job. I won't be setting the origin right now because I have to rotate this. Open the job and the model, select it, go to the edit menu, go to placement, check the apply incremental changes, rotate it twice by 90 degrees around the x-axis. Now I can double click on the job again. You can see the extended bounding box is way off, so I have to click the refresh button. Now I can select the corner, click on set origin, everything is correctly positioned. Select the bottom face and the faces inside the zeros. Those aren't selected when selecting this bottom face because they aren't connected in any way, so they are different faces. Create a new pocket operation, set the pattern to offset, the step over to 80%, and I can click apply. You can see now a lot of movements, a lot of airtime, so let's optimize that a little bit. Change the keep tool down and the min travel to true. Let's check the cycle time. It's 50 minutes. It's almost half of the initial time. And now I have all that I need in order to finish my project. I hope you like this project. I really loved working on it, even though in the end I kind of got frustrated by all the time that it took me to make it. I realized that it covers a huge amount of operations, a huge amount of situations, large number of workarounds. Some are better, some are worse. I've told about each of them, what are the good parts and the bad parts. I hope it will help to solve a lot of situations where the simple FreeCAD commands cannot do the job they are supposed to. Thank you for watching. I hope I'll meet you next time for the 10,000 subscribers button. Don't forget, if you want to support me, you can visit my Patreon page, subscribe, or buy just a one-time thanks, a $3 thanks, or a one-time $10 big thanks. So see you next time when we are going to be 10,000.